Yeah, recording is on. So I'll kick off. Hello, everyone. I'm Harmeet. I have Tim, who is co-host of this meetup. So today, this is a special edition. Normally, we run on every last Thursday of every month, but because of popularity of Nishant's talk and it was so awesome, so we were like forced to do a session, and it was like, yeah, everyone like asked for an extended session. So that's what we are doing today. So today, first we'll talk about Nishant will give a talk, and then we'll have a community marketplace. If there's anything that you want to discuss, you'll be given a minute. It could be a job that you want to talk about, or if you yourself are looking for a job, you can mention, or if there's a conference or something that you want to share with the community, you can do that in the community marketplace. So without further ado, I will hand it over to Nishant to continue with the talk, and that I will stop sharing my screen. Thanks. Yeah, over to you, Nishant.
Thank you, Harmeet. I'll just start sharing my screen. Give me a moment. Excellent. Can everyone, is the screen visible? All good?
Yes, all good.
Excellent. So yeah, first and foremost, thank you everyone for joining in. So today we're just going to continue on from where we left off last time around. And so just to recap on what we looked at last time. So we went through an overview of what Airflow is all about, how awesome it is. Touched on a few of the key concepts around what workflows in Airflow languages, so essentially DAGs, and the tasks contained within those workflows, and they translate to operators. We discussed 3 types of operators. We had action, sensor, and transfer. And we looked at a few examples to really cement those key concepts in the first session. So we went through a use case 1, which was more around creating a simple DAG and there was a live coding session where we sort of created a DAG from scratch, and we extended that use case to creating dynamic tasks within the DAGs as well. And we were on the 3rd use case when things had to be rushed a bit. So that's why I've got a kind of mention over there. So we might pick things up right from where we left off with use case 3. So for today's agenda, so like I said, so picking things up from where we left off. So we're going to delve a bit more into event-driven DAGs, how we didn't get a chance to go through what the code looked like, and we had to rush through the demo as well. So we will touch on that. Now, we're also going to touch on one of the questions that was asked in the last session was around how do you sort of introduce branching and sort of decision trees in your DAGs? How do you pick one branch over the other? So we thought it would be a good use case for a presentation, because that's a very common use case that we come across while designing DAGs as well. So we're going to answer that question via a live demo as well. Then we're going to go through another popular question that was asked in the last session was around AWS's offering for Airflow, which is MWAA. So we're going to look at, and we're going to address a couple of questions with that. Number 1, how does MWAA work? How do you set it up? And number 2 was, there was a question around how do you get things into production? How do you get it into a collaborative environment where other engineers can look at it? So we're going to take MWAA as a use case, and we're going to sort of push some code and essentially productionize in a way of saying. If we do get some time at the end, we're going to touch on a very important topic around Airflow components. So just a deep dive into what lies under the hood as far as Airflow is concerned, and some remaining slide from the last time around, which is lessons learned, which again we had to rush through last time. So just again, to recap, we were able to produce a very simple DAG last time around, and we learned how to add tasks, how to establish dependencies between tasks, and also went through how statuses sort of work when when you actually run a DAG. Then we looked at a custom Python program to essentially create dynamic tasks within the DAG, wherein you might have multiple tables that go through the same ETL process. So how do you avoid sort of hand coding, 20 or 50 odd tasks? So essentially using the programming paradigm, essentially using Python, doing a for loop, iterating through an array, and generating the tasks on the fly. So we're going to pick up things from here. So live demo around event-driven DAGs. So essentially in this particular use case, we're going to essentially look at an event-driven DAG. How do we go about designing that? Again, this is one of the use cases that I've picked up from something that I've experienced in the last couple of years in one of the client sites. So how do you essentially drive behavior of a DAG when you have to react to events? And then we're going to also touch on key concepts that we didn't get a chance to look at last time. Again, there was a question around how do you exchange messages between different tasks in a DAG. So XCOM is the answer to that question. So we're going to look at that. And we're also going to touch on connections. So essentially, what you're looking at over here is an example of a event-driven DAG. So when we are talking about event-driven DAGs, going back to what we discussed last time around the types of operators, one of the operators that I discussed was sensor operators. So just to refresh your memory on that. So sensor operators are essentially used for sensing on certain events to happen. It could be a file landing in a storage volume or an SFTP endpoint or a blob storage or S3 bucket or whatever have you. So one of the other examples that we're going to look at right now is sensing on an event arrival. If you have a message queue, and if you send a message, so you essentially react to that message and take certain decisions based on the message content, and you trigger the downstream processes accordingly. So essentially so before I sort of give you a walkthrough of what the code looks like, let me just open the DAG itself. So this is what the DAG looks like. So I'm just going to trigger this DAG because I just restarted my laptop and had to restart Airflow as well. So essentially, what we are trying to do in this DAG is, so number one, we want to react to an event arriving. Number two, when the event does arrive, of course, we want to read that event, process the message, and take a decision based on which we might trigger downstream DAGs. Number three, we also want to make sure that there's always a process that is listening to the queue. So when the next event arrives, that can be processed as well. So the use case for this is when you need to do a near real-time processing of a file. You're doing some curation process in your data platform. You want to sort of let's say standardize the date time stamp to conform with the Australian Standard Time, or you want to standardize the precision and scale of in numeric data types or something like that. Something that can be applied across all the data that you're pushing into your platform. So when you're doing that, so curation can happen as and when your data is available in your raw store, right? So when the file arrives, you can trigger an event based on which you can react to it, and you can essentially trigger a downstream process that curates the data based on a particular pattern, for example. So in this particular case, we've got a task called the pull SQS messages task. Essentially, this is a sensor operator, which is listening to an SQS queue, which we're going to push a message to right now. And once that message arrives over here and it has processed the message, in this particular step, it will determine the pattern. So what I'm trying to emulate over here is based on the content of the message, we're going to take a decision of which DAG I want to trigger for this particular content that I'm getting in the queue message. And then based on the determined pattern, I'm actually going to trigger a downstream DAG. So essentially triggering a DAG from this DAG. In parallel, as soon as I process the message, I've got another task over here, which is just triggering another instance of this DAG, the queue reader DAG, so that it can start from the beginning, the first task, and we again start listening to the queue, and this process can be repeated over and over again. So just to show you how this would actually work, so I'm just going to go to my console. Unfortunately, I've got my queue in a different region altogether, which I didn't realize after I had created it. So, a moment. So I'm going to send a message to this particular queue, and the DAG that I want to trigger is, if I just go to the main DAG screen, I want to trigger, say, ETL pattern 1. Okay, so I've programmed the DAG in such a way that it will just read the body message, and based on the content of the message, it will trigger the DAG with the same name. Now, of course, this is just a sort of starting point. You can take it further, wherein you have a well-structured message schema, which will essentially give you the location of the source file. It will give you other metadata about the file that you're going to process in downstream. And then based on that content, you can make a decision and then take it from there. So the message was pulled in. So just to show you the log over here. So we had the sensor checking for messages every so often. And at the very end, it was able to get the message. So it just says success criteria met. Now, just to answer another question from the last session, how am I getting the next task, which is essentially processing the message, to talk to this particular task, which has actually read the message from the queue. So there's a data exchange happening between this task and this task. So that's where XCOM comes into play. So XCOM essentially is a shorthand for cross communication. So if I just delve into this task again in the log, you'll see a tab up here next to the log button that says XCOM. So every time I'm reading a message from the queue, that particular message is available in the XCOM. Now, what I do is in the next task, I then pull the message from the XCOM and then do some post-processing on it. At the moment, it's not much. I'm just reading the message. Based on that, I'm triggering the downstream DAG. So if I go back to my DAGs view, so I was able to trigger ETL pattern 1. If you see the start time, it's around 6:20 local, which just happened. And go back to my queue reader. So I also instantiated another instance of the same DAG. So I again have a process now reading, trying to read messages from the queue, and as and when it is available, again, it will go through the same process. It will process it and trigger another instance of the same DAG. Any questions before we look at the code?
Nishant, I have a question. So about the XCOM, is there like any specific way to redact the message in the XCOM because it's visible from the UI, or any approaches that you would recommend or may have used or can think of?
So it depends. So because, just to sort of give you more context around XCOM, because the data that you see in XCOM is actually committed to the backend database. So you can choose to not use XCOM for that communication if you have sensitive information in there, because you cannot share, say, a file content. It has to be something around, the metadata. So that's the only use case that I have used XCOMs for is when I'm just exchanging metadata, and based on that metadata, I'm making a decision. Okay, I need to go, for example, S3 location of a source file, right, which triggered this event. So I just get the location, and then in the next task, I trigger another process which has the sufficient sort of access permissions or the roles to actually process that file further. So I wouldn't put any sensitive information in XCOM to begin with. Yeah.
Yeah, sounds good. Yeah, thanks.
No worries. Any other questions? Sorry, I'm not able to look again, like last time, I'm not able to look at the
That's
chat.
okay. It's just Tim here. I can't see any other questions in the chat. If anyone wants to throw something into the chat, please do. But I had one I was just going to throw out there just to challenge you, Nishant.
Yes.
Are you able to tell us anything about error handling? What happens if that current thing there, the pull SQS message, doesn't work or fails for some reason? Let's say it can't connect to SQS or something like that. What happens to this job? Because it won't trigger it to start running again automatically, will it?
So when you trigger it the first time itself, it will fail. Of course, it will indicate it as a failed task. We'll have a bright red color around it. So now it depends on the root cause. So if, let's say, for example, you've just mentioned the wrong credentials to access the SQS, then it has to be, well, fixed manually to recover. Now, in instances wherein, for example, SQS might not be the best example. For example, if you're trying to communicate with a database, right? And that falls over, right? And there's a downtime of 5-10 minutes, let's say the SLA is around 15 to 30 minutes to get it back up and running. So what you can do is in your tasks, you can bake in retries and retry delays to attempt that task again after 15 to 30 minutes based on whatever parameters you set. You can also use exponential backoff. So that's so every time you retry, the duration, the retry delay will keep expanding to a maximum level. Because of course you'll have to mention a threshold as to because the cause might be something else entirely. Let's say the database is down, or there's a DNS issue. Facebook.
Yeah.
So,
DNS issues, things where you're hitting APIs or something like that. Sometimes they're not available, and so they're the sort of things that sometimes cause issues with pipelines that are running. So it's great to know that it's got some ability to handle those or deal with those, and then you can automatically retry them. That's great.
And one of the other things, just to add on to that, one of the other things we looked at was other arguments that you can pass to your DAG, wherein you can do failure and success callbacks. So you can sort of tailor make some method or function that will do some remediary actions on failure. Of course, you've got email on failure as well, just in case you need to let your ops team know that something has gone down.
Sure. I think that might answer. Someone's popped a question in the chat that asks, the arrows going out of the node, can they represent success or failure and be triggered depending on the success or failure of a node?
Yes. Yes. So every node has a trigger rule. So by default, when you're creating a DAG, all the tasks, the default behavior is all the upstream tasks should be successful for the current task to execute. But there are other trigger rules that you can override. So you can say that if the upstream has failed, then do this. Otherwise, skip. So those sort of behaviors are something that you can bake into your DAG design as well. So I think that is something that we're going to touch on later in the session as well when we get into the MWAA stuff. So I've got an example over there which talks about trigger rules.
Sure, thanks. And we've got another question as well that asked, instead of using XCOM to pass information like a file name or something out of one function to the next downstream process, could you just return that value directly to that process without using XCOM?
No, because tasks in the DAGs are stateless in nature. So returning values won't work. You'll need some sort of a buffer, some sort of a store in the middle to exchange messages between two tasks.
Yeah.
I've seen use cases where people also have used, I think we touched on it last time, the global variable space, but I probably don't like that idea, because for every, if you if you have a lot many tasks in your, say you have hundreds of DAGs and thousands of tasks between them. So everything that you're adding in variables or XCOM is essentially going into the database. So you're going to sort of blow up quite quickly unless you're cleaning up on a weekly or a monthly basis.
Probably also a property, if I can interject, it's probably also a property of the fact that each task can get executed on a different node or on a different worker potentially as well. That's probably why you need that intermediate database or whatever to carry that stuff.
Exactly, yeah. So the Airflow components bit that I wanted to touch on later in the session will sort of maybe cement that understanding as well, because, so that works in a master-slave sort of configuration where you have a lot of worker nodes doing these tasks for you.
Oh, thanks. You can keep going now.
Awesome, no worries. So so essentially in the what I'm doing in the DAG is, let me start from the start. Of course, I've got a dummy task for the start task. Then I've got a queue sensor. So I'm using the SQS sensor operator, which is, again, it comes with the Airflow package. And the parameters that it accepts is the SQS URL, the max number of messages that you want to pull through, and the amount of time you want to wait for every poll that you're making to the queue, because you won't be continuously, like from a technical sense, it's not really continuously listening to the queue. It's just polling for messages every on a particular cadence, which you can control from here. Then you've got this AWS connection ID. So again, something we didn't touch on last time around was when you want to talk from Airflow to these different data stores or external systems, there's a concept of connections within Airflow, wherein you can essentially store your credentials that you're going to use to communicate with the database or communicate with, in this particular case, an AWS service. There was one question from last time around as to the security around these credentials. So they're encrypted when they're stored in the database, because, again, anything going in the connections are stored in the database. And it uses a fernet key when you're setting up Airflow in the config. You've got to mention a fernet key, which it uses to sort of encrypt. the credentials. Alternatively, you can use other backend providers. So Airflow has the capability to, say, integrate with the AWS parameter store, where you can actually, use encryption as well. So that's task number one. Task number two is, as soon as I read the message from the queue, so what I was mentioning was I need to trigger the instance of the current DAG again to get another process listening to the queue. So I'm using a trigger DAG run operator, again, comes inbuilt with Airflow, and the trigger DAG ID is this DAG, the DAG that we're looking at right now. Process message task ID is essentially a Python operator. So I'm just using a Python function over here, and it's doing nothing but it is grabbing the message from XCOM, and it is printing it, and then it is just pushing another XCOM value with the DAG name. Now, the reason why I did this was not, why didn't I directly trigger the DAG? What I wanted to show here was you can read any message. You can implement your own algorithm, your own logic to determine what your next downstream downstream DAG is going to be. And then you can push that back to XCOM. Going back over here. And the last operator that I've got is the trigger DAG run operator. Again, this time around, I'm triggering another DAG. But the DAG ID, this is where the Jinja templating capabilities of Airflow comes into play. The DAG ID is again pulled from XCOM. So that's how I'm triggering the DAG, the downstream DAG. And then at the end, we sort of just end the process, and the relationships, again, we went into a lot of detail around how do you establish this relationship. So you've got the T start. So essentially you use the bit shift operator to establish relationships. So we go start to sensing the queue. Then after reading the message from the queue, we trigger two tasks in parallel. One to trigger the instance of the same DAG, and one to process the message. And from processing the message, it sort of goes on its own path. Once I process the message, I trigger a downstream DAG, and we end the DAG right here. So that's essentially use case 3, which we couldn't look into much detail last time around. Any questions before we move on to the next use case?
I think all good. You can keep
Oh,
yeah.
Excellent. So the next, sorry. Yeah. So just before we proceed, just to recap, so we looked at how we sense event, how do we determine action, how do we trigger downstream DAGs? So you use the trigger DAG run operator. What is the use of XCOMs? How do you get two tasks to talk to one another? And connections. So essentially use connections to establish connections with external systems that you're talking to. Just before I proceed, just to show you what the connections look like. So that comes in the admin tab. And I've just got the AWS default connection. And I've got the, the names don't really make sense at the moment, but the client ID is a login, password is hidden, of course, which is my client secret. I'm using client ID and secret at the moment. But if you have Airflow and AWS, please use roles. So I'm just using this for the purposes of the demo. So the next use case that we're going to look at is essentially answering another question that we got last time around, was how do you do conditional flows with DAGs? How do you sort of branch out and choose one path over the other? And while doing that, we're going to also touch on 3 more concepts. Number 1 is the task trigger rule. So one of the questions that was asked earlier today was, how do you sort of change the rules of when the tasks have to be triggered? So can you triggered downstream based on failure or success. So we're going to look at that as well. How triggering DAG with parameters. So you can trigger DAGs and pass in parameters to the DAG as well. So it will come in very handy when you're triggering one DAG to the other, wherein you want to send the file location, for example, for curation, right? And then using global variables. So we know that Airflow has the variable space, but what are the use cases? When do you actually use it? So we'll just start simple. So I'm just going to live code the branch operators part of things, and the rest of it we're just going to walk through something that I've already deployed in AWS managed Airflow, and we can also look at MWAA in the process. So at the moment, I've got a DAG called branching DAG, which has nothing besides the start and the end tasks. So we essentially will be looking at how do you sort of use branching in your DAGs, right? So this is the DAG code. So I've got the branching DAG, I've got the start and end, I've got nothing in the middle. So what I'm going to do is I'm just going to going to create this task. So I've got a pre-process. I've got a task called check something, which has a different color. I'll tell you why that is. And then I've got two paths to follow. So let's do that quickly. So in an ideal scenario, you'll have some sort of a pre-process happening, which before you make a decision. So I'm just going to put that in. It's just an indicator. Could be you can skip it if it doesn't suit your use case. Then the next task that we're going to do is going to be around making that decision. So I'll just name it something like a condition. So one of the branch operators that you can use is called the branch Python operator. Now, the way this works is, of course, as in all the tasks, there are two compulsory parameters. So you've got the task ID, which will be the name of the task, and which DAG does this task belong to, as in which DAG object. Now, in order to make a decision, of course, you'll be doing some sort of if-else sort of a logic, right? So you want to make a decision based on which path to follow in your DAG. Now, before I expand more on the T condition, I'll leave this blank for now. I'll just create my paths, right? So let's say I have path 1 and task 1, for example. Again, I'm just going to go with dummy operators at the moment. So let's say path 1, task 1. I'm just going to copy this and create another path. Path 2 and task 2. Again, I'll make sure that the name is unique. And the branch Python operator, I'll just make sure I check something. All right, let's check something over here. Cool. So similar to Python operators, the branch Python operator receives the same set of arguments or parameters. So in Python operators, you pass an additional parameter called Python callable, which is nothing but the name of the function that you're going to, or the Python function that you're going to trigger to make the decision over here, which path you want to take. So I'm just going to create a function. Let's say check. Again, I'll just name it the same, check something. Cool. Now, of course, I don't have a function by that name, so I'll just create a new function. So if I just do check something. So the way this the way the Python branch Python operator works is you call this function, and the name of the task ID that you want to trigger at the after evaluating your condition or whatever checks you're doing has to be returned as a value out of this function. So what I mean by that is if I want to trigger path 1, I need to return the task ID for path 1, right? So we'll see this in action. And before I do that, just to extend this a bit further, actually there should be this, and what I'll do is I'll remove the end operator and just put path 1 in so that we can sort of see the branches properly. And again, path 1 end. Again, I'll just copy this and do a path. All right, again, to establish the relationship. So number 1 is our pre-process. Then we go to our T condition. So this is where we are evaluating. Now from here, conditions downstream, even though we might take one path over the other, but we still have to establish the relationship signifying the fact that it can go to either. So the downstream for this T condition task is both path 1 and path 2. So I'll add that and path 2. And then each path, they take their own sort of journey. So I'll just put in this and path 2. Just put in that. Save this. And go back over here. Give it a quick refresh. And that's what we have, right? So we've got, because we've added new tasks over here, so the statuses are a bit out of order. However, so I'm gonna trigger the DAG in a bit. Essentially, in the function, we are returning path 1 underscore task 1. What that means is when I trigger the DAG, a new instance of the DAG will be created, and we will see path 2 getting skipped totally, and we'll only see the path 1 getting executed. So I'll just trigger this. And there you go. So path 1 is executed as opposed to path 2. Now, of course, right now I'm sort of hard coding this. We're going to go through an example with MWAA where we can make this behavior a tad bit more dynamic. So I'm going to extend on this example, but we'll do it in AWS instead. So we can sort of hit 2 birds with 1 stone. Any questions?
Nishant, we have one in the chat. So Ayush is asking if we can do this whole thing in one line, like T condition and the bracket.
At the front door.
Sorry. So yeah, if you can look at the chat, he's pasted the whole syntax. That can we do it in that way?
The reason why we cannot do it in one line, at least with this method, is the fact that if I was to put in something like this, actually, you know what? Let's see what happens. Because they go on their own path, what we are essentially saying with while using these bit shift operators is that once this is completed, these 2 things can run in parallel. But when we sort of fork out, you can only merge, if you were to have one common end task, this would work. But when it comes to doing many to many, because what you essentially are saying when you're trying to do that, even though Airflow won't accept it at all, what you're essentially saying is T path 1 end upstream is path 1 task 1 and path 2 task 1, right? So there's a sort of a crisscross of dependency that you would be trying to emulate, which Airflow won't accept in this sort of a method. But if you had things merging back in, so if I had, let's say, something like this, and let me just comment this out, something like this, and if I just save this, then, well, okay, I've got another relationship happening over here. Comment that out. Interesting. Let me just change this to. Okay, there you go. And I've got the orphan task over there because I didn't delete it. Anyway, so you can actually merge back into one and you can accomplish this use case in a single line. But when you have things forking out, then in those cases, you'll have to use sort of multiple lines and let Airflow do the heavy work of parsing them. And
sorry, what I wanted to ask was the array that you had, the array that you have there.
Yeah.
The array is basically comma-separated parts, right?
Yes.
So what I wanted to ask was, can the elements of these array, can they be the whole DAG part itself? Can an element of array could be the line 59 itself?
I don't think so. That's a good question. I've never tried it. We can try and break it and see what happens. But I don't think it accepts that. Let's see. Oh, there you go. It can. I've learned something new today myself. Thank you, Ayush. Yes. So actually, let's take this further.
Interestingly, I wonder if that was still connected to the right place from the T condition. Was it connected to the task or the end of part 1?
Good question. Let me just get it back into the previous state and try to emulate what Ayush is saying. Yeah, it has totally messed it up. Maybe fresh this part. Create a fresh tag altogether. So that's actually, that brings me to another point. When you have a lot of changes that you're doing to your DAGs and task, Airflow does act up a bit because it tries to, when it is parsing all of these DAGs, all of the information is going to the database. So if you have major updates to your DAG that you're doing, it's always recommended to sort of version it somehow by naming it. It's a bit of a quirk with Airflow, or you sort of reinitialize the database every time you're refreshing DAGs in Airflow. So let me see if we can show up.
I don't want to mess your presentation up, Nishant. I'm just wondering, because if you notice that check something is now pointing to the path 1 end and path 2 end, I'm wondering if you used the opposite bit shift operator, would have been connected in the right way.
So instead of...
instead of saying that the path one end is downstream, what if we said it was upstream to path one?
Oh, gotcha. So
that probably won't work either. Sorry. Keep going with your presentation.
Yeah, I think it somehow it's acting up. There you go. We finally got there. You're right. Thank you, Tim.
Very nice.
Nice. Yeah, we got there as a team. Excellent. Yeah, so the answer to your question, Ayush, is yes. Yes, we can.
Right.
Excellent. Any other questions? Cool. So now the next bit that I want to touch on is, and we're going to extend on this example a tad bit more, and that would be the last use case that we look at. So which is the MWAA, so which is the managed Airflow offering that AWS comes with. When you want to use Airflow and you want to put it into a collaborative environment, at least up till I think 10 days back, I hadn't actually used MWA myself. I've used Airflow in AWS, but it was just sort of self-managed and self-deployed into Elastic Container Service and such. But it seems to be the path of least resistance and the easiest way to sort of get you from zero to some sort of a production or collaborative environment. So we're going to look at how do you set up an Airflow environment in AWS. There are certain prerequisites that you need to do, of course, to get the whole setup working. So you need an S3 bucket. Again, S3 bucket for the uninitiated is think of it as a Dropbox, but you sort of can store any blob item, and it has some some AWS specific bells and whistles around it. You can host websites and all that sort of stuff. But we're just going to use it as a simple store for where we're going to place our DAGs in. I'm also using Code Commit and Code Pipeline. Again, these are two services provided by AWS. Code Commit, again, for the uninitiated, it's nothing but a Git repository. It's AWS spin on a GitHub, if you will. And Code Pipeline is, again, nothing but a CI/CD tool that is provided by AWS. So what we are going to do is we're going to create a DAG, or at least look at an existing DAG, publish some changes to it, and we'll see it going through to Airflow in a prod-like environment. So for MWAA, so number one, of course, you need to sign up to AWS. And when you go into AWS, the first thing, of course, it provides you a lot of services that you can play around with. But the one that you're, of course, interested in is MWAA, which is managed Apache Airflow. So that's the page I was on anyway. I've already got an environment over here. The reason for this is because when you set up the environment the first time around, it takes about 10 to 20 minutes to boot up completely. But the best part, when you're even setting up from scratch, the best part of it is if you have your S3 bucket sorted out before, it's a breeze to set it up, because the CloudFormation template is already available over there. You just have to select certain options, click certain buttons. It'll set up everything for you, whatever you need in terms of VPCs and subnets and everything else that goes into setting it up for your usage. So I'm just going to go through the process, but I'm just going to cancel it at the end because I already have an environment. So I've got a S3 bucket already, which I'm using for another environment. So I'm just going to choose that. So when you choose the bucket, it will ask you where are you going to place your DAGs? Now, what happens is, and this is true, it's not just for AWS, it will be true for any place where you're hosting Airflow at, is there'll be a common there'll be a common place where you'll be putting DAGs, the DAGs folder. So now going back to the conversation of working in a master-slave sort of a configuration, if you have all your Airflow components working on independent nodes, as it is suggested in production, of course, you wouldn't want a whole bunch working on a sort of a monolithic server, if you will. All of these nodes should have access to the same set of tags, right? The same files. If there's any change, you'll see some flaky behavior on the UI. So, you click once, you'll see a different DAG definition, and the next time you click, it might be picked up from a different node and all that sort of stuff. So the best way to get around that problem is, well, number one is you push the same DAGs folder, or you deploy it in 4 or 5 different servers, or all the worker nodes and all the master node, which is the scheduler and the web server. So you deploy the same set of files everywhere. That's one way of doing it. The common way that I've done it in the past is I use some sort of an NFS. So in AWS, I was using an EFS, and I was placing the DAGs in a common location, and that location was essentially mounted on all the containers that I had as a volume. And invariably, they'll have access to the same file for the reason that they're accessing the same files, right? So similarly, when you're setting up Airflow from scratch, there'll be more stress on where you want to place your DAGs, where your DAGs will be, where your logs will be, and so on and so forth. And that you can sort of work from there. How do you push your DAGs in? How do you get your logs out of that location and do certain, conduct certain insights, have some insightful queries around it, so to drive alerts or stuff like that. So I'm just going to put in the required information, which is the DAGs. The others are optional. So I'm just got a DAGs folder over here. I'll choose that. Next. Now here is where the power of this comes into play, where you can essentially create a VPC, which is a virtual private cloud. So if you are sort of setting it up in a organization, you will be placing most of the things in the private subnet, because you don't want it exposed to the outer world. It should only be available to your WAN and to your local company network. So I've already got that created earlier, because again, if I select that, it'll take a bit of time to sort of churn through and create those VPCs. At the moment, I've gone with a public network setup because, of course, I wanted to expose this to the internet so that I can walk you through the demo. But ideally, the recommended way is you go with the private network, right? So in terms of the security group, again, it'll create the security group for you. So it's essentially the firewall rules to allow traffic on ports or deny traffic on certain ports. So all of this will be taken care of by AWS itself. So in terms of environment class, again, you have the choice of the capacity that you want to bake into your Airflow setup. So scheduler is the master node, if you will, and the worker node is your worker node that's actually going to execute the tasks. Web server is where you're hosting the UI side of things. You can also define the maximum worker count, so it will scale in and out automatically based on the load that Airflow is getting. So if you have, let's say, just one DAG working, I think it can be accomplished by one worker node, as opposed to, let's say, thousands of DAGs. In those cases, you would need some way to scale it up, scale out and scale in when the load is less. Just going to skip through these. Another question last time around was around how do you sort of aggregate these logs and how do you develop insights around it. So I'm taking AWS as an example, and I touched on the how you can push your logs to CloudWatch, and based on that, you can have certain insightful queries happening over there, and can trigger notifications and so on and so forth. So we're going to look at a live example of that as well. And again, you'll need execution roles. So this is something that, again, AWS will take care of for you. And once you have done all of that, you just got to click on create environment. It takes about 10 to 20 minutes before things come up. At the end of it, you'll see a new entry in your environments list, and it'll have a nice little link over here to access the Airflow UI. So I'm just going to click on that. And that's the UI. Now, at the moment, I've got some DAGs, and there's the same DAGs that we've been sort of talking about and working with in the last demo and sorry, the last session and this session. But I'm going to push a new change, and we're going to see how things work as well. So that's MWAA. The other things that I've set up, as I was saying, I've got a code commit Git repository, and I've got code pipeline as well. So what I've done is I've just set up a simple Git repository called Airflow DAGs. Again, the structure within this is I've got a folder called DAGs where I plan to push all my DAGs in, all my files in. And then I've got a very simple pipeline for which I'm using code pipeline called deploy DAGs. For which I'm just grabbing the source code from the Git repository, and I'm sort of continuously sort of delivering and deploying it to the S3 bucket location, the DAGs location. That's where the Airflow picks it up from. Yeah. Now, of course, in a more in a proper setting, you would also have a build a CI step in the middle to run tests and such. Make sure that sanctity of the code is nice, it has nice code coverage and such, but I just didn't get the time to set that up. Sorry about that. So we're just going to look at this cycle. Now, in terms of branching DAG, so we looked at, sorry, give me a moment. So we were able to sort of do this, right? So we were able to create this DAG. So I just wanted to take this example further, wherein we want to pass parameters to the DAG, based on which we make the decision as to, do I want to go with path 1 or do I want to go with path 2, right? Now, just so we have that in the right order, and I can switch back correctly. Excellent. So what I'm going to do is the way I'm making that decision at the moment is driven by a parameter that I'm passing to the DAG, which has the parameter that I'm going to pass to the DAG. The key is source, and the value will be, let's just take for this particular example, you can say it's a source name, right? Now, once I take, once I have that value, say, let's say source is X, right? Now for the source X, what is the configuration? Is it path 1? So let's imagine you have like 5 paths, right? And you have 100 odd sources which can choose any of these paths. But you need a place where you can actually configure this behavior, that source 1 will be following path 1, source 2 will be following, say, path 5, source 3 will be following path 6, and so on and so forth. So that's where I'm using the variable store for. Now, hopefully, it's still there. I'll just go over here. Yeah, all right. So I've got this variable store where I've got a couple of entries over here, the key being the source name, for example. In this case, I'm just using source 01 and source 02. And the configuration that I'm setting up over here is source 01 should be following path 1. and source 02 should be following path 2. So what that means is when I trigger my branching DAG, so when I trigger my branching DAG and I pass a configuration for source as 01, it will go to path 1. And then if I pass it at 02, it will go to path 2. So the way you do that is when you trigger, of course, I'm triggering it manually, but you can actually do it automatically as well. So the way this works is you trigger the DAG, and the first thing the page that you see is for you to mention a configuration JSON. This is nothing but the parameter set that you want to pass. So in this particular case, like I said, the key that I using is source, and the value will be the source name. So it's source 01, for example. So I'll just trigger this. Go back to graph view. So I've triggered that. And as you can see, it is following path 1. Now, if I do the same thing, just to make sure this works, if I do source, source 02, I trigger this to the graph view. So it is taking path 2, right? So the way we are achieving this is, if I go back to the example, so the number of tasks is exactly the same. So we've got the start, we've got the pre-process, we've got the branch task, which was a condition task. I've got a path 1 and path 2, and I've got a path 1 end and path 2 end. And just for kicks, I've just added a post-processing, which we can use as a trigger rule, right? Where we can sort of highlight the trigger rule aspect of things. So the way I'm doing this is essentially when I have to make the decision of branching from between path 1 and path 2. Of course, I'm triggering this Python function called branch. Now, I've added additional parameter over here called provide context. What this does is it will send certain arguments, keyworded arguments to my function, which I can access within my function. And the content of this keyworded arguments would be essentially the context around the DAG and the tasks and so on and so forth. Now I can use that keyworded argument to access XCOM values. I can use those keyworded arguments to access the DAG config, as in the parameters that I just passed earlier. So those are the two things I'm using. So if I look at this, so the additional thing that goes over here is, the keyworded arguments with a double asterisk, which means the number of arguments that are getting passed, and Airflow is taking care of this for me. And I just access the keyword argument called tag run, and I get the source. So source is the key where I was passing the parameter to. Similarly, I've got, I'm accessing a variable. So remember, I'm getting source 01, but the path value, I'm storing it in the variable store. The very simple way of accessing the variable store is using the Airflow, the variable, importing the variable library for importing variable from Airflow.models library, and essentially doing a variable.get on the key name. So I'm getting source 01, so I'm passing that over here, which determines the path. And then that's what I'm returning at the end, so which is path underscore task one. That's how I've named the task IDs. So that's how I'm driving this behavior at the moment. Now you can sort of combine this concept with the SQS sensor side of things, wherein you can get a message with some metadata in it. You make a decision based on that, which pattern tag you want to trigger. Within that pattern, there are different happy paths. And based on the source type So you can sort of make that decision. Do I want to go with part 1, part 2, part 3, and part 4, so on and so forth. So if I had to push any changes to this tag, for example, I'll just put something in the end just to portray how this continuous delivery kind of works. So let's just put the test, and let's just use another dummy operator for example's sake. Just the test. So I've just added a new task. I'll add a new relationship. So post processing is the test, and I'll just push this to my Git repository. So as soon as I push it, and if you blink, you miss. That's how that's how quick it's going to be. As soon as I push it, this pipeline will trigger. Give me a moment. Yeah, so this pipeline triggers, which will accumulate the code from the Git repository. Of course, it's recommended that you have a CI step in the middle as well to run the tests and so on and so forth. And then eventually it will deploy the DAG definition to that S3 location. And as soon as it does that, and if I just refresh this tag now, so you've got the new task over here. So this will at least sort of get you started on using a managed service without having to host one for yourself. Like I said earlier, there are some quirks around MWAA, at least based on the developer testimony that I have received from other people. I haven't used MWAA in a production environment myself at a client site. So for larger workloads or more number of DAGs, it's of course recommended to do your performance benchmarking and your regression testing to make sure that the system holds up pretty nicely. Any questions?
I just had one I was going to throw in.
Yeah.
Do you have any thoughts, and I suppose it's a bit of an open-ended question, do you have any thoughts about the cost of running MWAA in AWS as opposed to a self-managed cluster in AWS? Does it cost a lot more, or is it kind of worth the cost because you're abstracting away all the complexity?
So there are two elements, so there are two answers to that question actually, because of course there are two costs that we then need to talk about. One is the operations team that will have to manage the platform in case they are sort of deploying their own solution. So of course, there's that cost. In terms of the infrastructure cost, because of course I'm running with very low grade infrastructure at the moment for test purposes, it's really driven by the amount of CPU and the RAM and all that sort of stuff that you're going to end up using for your nodes. So there's a bit of a balancing act going on over there. So you can sort of save costs on infrastructure if you go with something like an ECS or an EKS for that matter. If you have a Kubernetes setup for your platform already and you're just using it to host Airflow as well, in addition to other things, you can save costs on just hosting it on an ECS as well, because you can sort of kill the tasks and bring it up automatically to your own accord. But then you have the additional cost of people actually sort of maintaining it and patching the underlying the Docker daemon setup and all that sort of stuff.
Yeah, sorry, it's a bit of a difficult
question. No,
that's
a totally valid question though. Yeah.
If someone said it's going to be 10 times the cost and it's going to cost you, $10 an hour to run MWAA versus spinning up similar infrastructure, 2 servers or 2 nodes or whatever, then that might influence my decision. But from what you're saying, it suggests that maybe there's not a massive difference, and it might depend on what your costs were for managing.
Yeah, I mean, if you it's just so if you're setting up your own team and you're setting up your own infrastructure, that's just, you just have to evaluate as the juice worth the squeeze. Like, can you just get started and get more business value out of things if you go? It's the answer for any sort of managed service that you end up using, right? So, yeah, it has to be driven by those factors. Plus, the costing itself is all over here in terms of. So they cost it based on sort of price per hour for the amount of worker nodes or and scheduler that you're using. So if you go with something higher, and they also say how many DAGs you can sort of execute. So if you have thousands and thousands of DAGs, of course you go to the top, and you being charged 99 cents an hour. Which is not much, actually. Yeah.
Someone's just popped in another question and said, could you push the DAG one more time?
Sorry?
Could you push the DAG one more time? What if you make another change to this and did another push?
Oh, yeah, sure. I'll just add another task, or should... Yeah, sure. Let's do
I guess so.
Let's do test again.
I'm not exactly sure what A was expecting you to demonstrate, but yeah, they just asked you to do another push and see that. I presume that will now trigger your code pipeline again and update those DAGs in S3.
So I'll just refresh the screen just to make sure that you can see it in action here. But all right, so it's deployed. Going back to, sorry, this is the and refresh. Yep, let's test again. So was there a specific sort of doubt around that?
Sure. Does A want to? You can unmute yourself if you want to join the conversation, or hopefully that addressed what you were hoping to see.
Excellent. Any other questions? How are we doing on time, by the way?
I think it's getting on a little bit. Did you have anything else you wanted to sort of tick through?
Not really. So I think I have the Airflow components bit, but I think we can just skip that for now. One thing that we missed out on last time around was essentially around the lessons learned, which we didn't get a chance to go through last time around. So I just wanted to go through that.
Yeah, if you want to go over this for a few more minutes, that'd be great.
Yeah. So in terms of lessons learned, at least, again, this is purely based on my experience with Airflow in the last 2 to 3 years. I've always found it simpler for the ops and the support team if you have your DAGs designed really simply. Yes, you can go through one whole process in a single DAG, but you don't have to, because these things can get complex really soon, and then UI sort of ends up looking like a Jackson Pollock painting. So the message here is just keep it simple. If you can sort of separate it out into manageable chunks, and you can trigger one from the other, and you can use external task sensors as well. Let's say if you have got a DAG which is waiting on a task to be completed in another DAG, you have all of that capability built into Airflow, so you can take advantage of it. So the idea is keep your DAGs very simple. Dynamic DAG generators. I think every organization using Airflow does this. They have some sort of a dynamic DAG generator. It achieves two things. Number one, of course, you don't have to hand code every DAG ever. It lowers the barrier to entry for data engineers to also contribute towards scheduling and sequencing of jobs. So if you have, let's say, a simple configuration file like a JSON that you're using in, and you have this custom Python code that just generates the DAGs on the fly based on what you've got in the config file, comes in very handy, and make sure that the whole team is sort of contributing to that space rather than just one person who is an SME just doing Airflow DAGs. Understanding how Airflow components work, this comes in very, very handy if you're troubleshooting issues, especially when there's no code issues, but there are infrastructure issues, and you cannot really pinpoint what's wrong when you're looking at the UI. You see some logs missing, you see, and this will happen invariably if you've got a lot of workloads and you've got a lot of worker nodes. So it's very important to understand how Airflow components work themselves to actually troubleshoot the issue. You need to understand how Airflow works under the hood, how it schedules the tasks, how does it end up being executed by a worker node, and what happens before and after it. So, in terms of supporting the solution, this comes in very handy. Airflow scheduling. So this is something that I struggled with when I picked up Airflow for the first time. What I assumed was when you schedule your tags, let's say you've got a cron schedule or you've scheduled it to run it daily, right? Or hourly. So what I thought was if I've scheduled to run it or to run it, let's say every hour, what I assumed was it will run on the hour. So let's say if I've scheduled something to run at 2 p.m., it will run at 2 p.m. What I discovered was the way Airflow calculates the scheduling of the DAGs is a tad bit different. It calculates between the start date plus the duration. So it will execute your DAG at the end of the hour. So a 2 p.m. DAG will actually run at 3 p.m. And the reason behind that is when Airbnb came up with the Airflow setup, they wanted to sort of emulate the behavior of they wanted to do batch processing. So I'm processing yesterday's batch today. So if I'm triggering a DAG for yesterday, today, essentially I'm consuming yesterday's data and doing a batch processing from yesterday. So that's a bit of a quirk. It gets a bit to get a hang of. Like on the surface, it should be very straightforward. I hope it comes pretty straightforward to every one of you, but it took me a bit of a time to sort of catch that drift. Jinja templating in Airflow, again, we saw an example of that. It's pretty powerful, especially when you're sort of switching from a dev environment to sit environment to a pre-prod or a UAT or a performance environment where you have to switch variable values or certain naming conventions across environments. Jinja templating comes to the rescue in those instances. So yeah, that's another concept that comes in very handy. Last bit is about custom operators. So we've been talking about these action operators. We've been talking about sensor operators and such. You can create your own custom operator as well based on any of these. Let's say at the moment, for example, I can only trigger one DAG at a time, like when I'm using trigger DAG run operator. But I want to trigger multiple DAGs. I want to trigger 5 different DAGs. So you can actually create a custom operator that does that behavior. And that is an actual use case that we did last year or so. So encapsulating sort of bulk behavior into one solid operator. That comes in very handy as well. That pretty much brings me to the end of this session, and I'm glad we could do it in time this time around. And the demo gods were with us today.
Yeah, thank you, Nishant. That was fantastic. Does anyone have any other questions for Nishant? Once we sort of address any questions, we'll move on and have a look at the marketplace, if we spoke about at the beginning, and we'll open the floor if anyone has anything they wanted to share, which might be somebody's looking for work or for a particular job opportunity, or they might have a job opportunity that they're looking for people for, or you can talk about some technologies or projects and stuff that you might be working on. We're always excited to hear about those sorts of things. I can't see any other questions. So with that, let's move on to this is the one. With that, we might move on to the marketplace. You can feel free to unmute yourself if you'd like, if you have anything you'd like to share. I'll also add that we've recorded this session, so we will post the video for this on the Meetup page for this particular talk. So if you want to watch it later on, then you can always have a look there. And likewise, if anyone has any information they like to share in the marketplace, then you can also post links and things there. If someone has a job opportunity or someone is looking for work, then you can put a post on there and say you're interested in data engineering work or something like that. And recruiters and other agencies and people can pick that up, and they might reach out and get in touch with you if you wanted it on there as well. Cool. I don't think we've got anyone else, any takers for Marketplace. So we'll say thanks to ThoughtWorks, who provide the conference facility and everything and help out. So thank you, ThoughtWorks, for enabling the Data Engineering Melbourne Meetup group is really good. And the next exciting bit I just touch on is the next meeting is actually going to be next week. So that falls in line with our regular last Thursday of each month cycle. It'll be on the 28th at 6 p.m. And we're going to look at stream processing through Apache Kafka, which is going to be really exciting. So we're going to have a live demo again of people doing that. It's a totally different sort of platform to Apache Airflow, but really exciting stuff as well. And so we hope you'll be able to come and join us next week for that. If you have any questions, feel free to reach out to any of the Melbourne data engineering organisers. So Andrew Jones, Amit, or myself. Our contact details and email addresses are on the slides there. And feel free to reach out to us if you've got any questions or any topics you'd like to talk about as well. If there's particular technologies you're working with in the workplace or anything, then feel free to reach out to us and let us know, because we'd love to either help people develop talks and share a bit about these new things as well. Thank you very much.
Thank you.
Thank you, Tim. Thank you, Armi. Thank you for organizing this.
Thanks, Nishant. Thank you, Tim.